What's up, everybody? It's Coach Sharf. Welcome back to my Algebra 2 notes videos. And today we are going to do a little quick review on some of the stuff from Unit 3, the polynomials unit. I am recording this in the 2021-2022 school year. It's probably only going to be good for one more year. Algebra 2 standards are changing after next year. So we'll even see if I use the same video next year. Might add some more things, but for right now, for this current school year, this is going to be our review. So we got to go back and talk about longest synthetic division. This January 24th. It's been almost 2 months since we first did that after Thanksgiving. Took us a while to get through the packet. It's almost better that it carried over this semester, I think, because if we'd finished it first semester, then it would have been a while since we'd seen it. And then we've been doing some of the graphing characteristics. The graphing characteristics, if I do those, if I record a video for those, they'll be in a separate video. Otherwise, I'm going to go over them real quick for each class before the test, Wednesday and Thursday. But I want to go ahead and jump in with this review. I don't want it to be too long. One, for y'all's sake. Two, I got to get over to baseball practice. Let me actually share active instead of just clicking on it. There we go. So Unit 3 review. So there's 5 or 6 questions based on longest synthetic division. And pretty much those 2 questions are going to look like this. So it's either just going to be asking you a straight division question like I am in number 1, or it's going to say, what is the remainder when you divide the bigger polynomial by the binomial? So if you get a question like question number 1, that's all it's going to say. It's not going to, it's not going to ask you what is the quotient or, what do you get when you divide this? That's all it's going to say. So you have to divide it. Normally you can use longest synthetic division. I picked this problem for a reason though. We have to use synthetic division because of the 3x. When I have the coefficient on x, you have to use I might have said synthetic division. I'm sorry. You have to use long division when you got the coefficient on x. So we have to use long division. So we're going to start with that one. So again, trying to note things as I go along, you'll see on the test. There's one question that's like this on the test. I believe we're actually dividing by 2x plus 1, where I'm going to have to use long division. Everything else I can either use long or synthetic, but I have to use long division here. So all we have to remember about long division is I'm trying to match the first term of my divisor to the first term I have left in my dividend. So I got to match 3x to 3x cubed. I have a 3 and 1x here, 3 and 3x is there, so I'm missing 2 x's, x squared. I'm going to distribute and multiply. X squared times 3x is 3x cubed. X squared times 2 is 2x squared. So again, the idea was to get these to match because now I got to flip the signs on what I just got. Now 3x minus 3x cancels out. Negative 19 and negative 2 give me negative 21x squared. I bring down the next term and I keep going. I got 3x, negative 21x squared. Remember, I'm multiplying, so I'm not doing 3 minus 24 to get negative 21. I got to do 3 times negative 7. I have 1x, I need 2, so I need 1 more x to get negative 7x. I distribute again. Negative 3x times negative 7x is negative 21x squared. 2 times negative 7x is negative 14x. Again, I have negative 21x squared matching, but I got to change the sign so it'll cancel out. 22 and 14 is 36x. Bring down your last number, 20. 3x, 36x, got to get it to match, so I'm going to multiply by 12. Again, carry it and distribute. 36x plus 24. What some of y'all might remember now is most of the problems when we did this, back when we first learned it after Thanksgiving and on the worksheet, at this point, we got a match. Everything would have canceled out. All right. Give me a second. Got my little thing. Or we got a match, so it would have canceled out. But it's not an exact match here. 36 minus 36 cancels. 20 minus 24 is -4. So I've got a remainder -4. I'm going to hide my head for a second. Got a remainder -4. Problems we've seen before. Again, we hadn't really seen remainders. I told y'all we could get them. We really hadn't seen them though, because in the packet, we're always trying to get a remainder of 0. So now we have a remainder of -4. I told y'all I would show y'all how we got to deal with it. So I'm going to do that. What I'm going to do though is I'm actually going to do a short long division problem with regular numbers. 10 divided by 3 goes in 3 times. 10 minus 9, I have a remainder of 1. If I actually divided 10 divided by 3 in my calculator, however, I would get 10.33333 repeating forever. That decimal, again, I'm ignoring this 3 for a second. Ignoring that 3 for a second. I don't want to scratch out the decimal. Ignoring the 3 out for a second. So 0.33333. I asked y'all in class, what fraction represents 0.33333? So y'all told me 1/3. So I'm sitting right next to them. I have to undo to get the scratch. Y'all told me 1/3. So 3.33333 is the same thing as 3 and 1/3. Where do I get the 1/3? 1 is my remainder, goes in the numerator. 3 is my divisor, goes in the denominator. So my remainder and my divisor make this fraction. 3 and 1/3 make the fraction in my mixed fraction. So I got to do something similar here. I'm not just going to stick it on the end. I still have to use a sign. Since this is -4, I'm going to subtract. Minus 4 goes in the numerator. 3x plus 2 is going to go in the denominator. So when I divide this, my whole answer is the whole quotient, x squared minus 7x plus 12, with the fraction representing the remainder on the end. Again, something new we haven't seen. I know one question on the test, the very first question, we're dividing by x plus 2, not 3x plus 2, but all of our answer choices, they have a polynomial, but they end in, try to do dots. They end in like plus 3 over, I think it's actually k. So k plus 2. Dot, whatever the polynomial is. I don't want it to connect. That's one thing I don't like about this thing. Minus 5 over k plus 2, something like that. So on that first problem, they all have the k plus 2 in the denominator. We would have been doing, again, k plus 2 over here. So hopefully y'all can make that connection. Then that's how I got to write the denominator. One of the other problems might even be the 2x plus 1 one. I'm not sure. It has 2 answer choices that have, if it's the, I don't know if it is the 2x plus 1 one. 2x plus 1 and then 2 don't have a fraction for the remainder. It just, it's a regular quadratic without the remainder, because there's a possibility you might divide and you got a remainder of 0, so you wouldn't have the fraction remainder. So there's that. Got to write the whole quotient. Second question. What is the remainder when you divide big polynomial by x minus 4? So now it's just asking for the remainder. So with this problem, I could still do long division if I wanted to. Okay, I could still do x minus 4, 3, the whole thing if you want to, all right? I'm not going to write the whole thing out. You could do that, but since it is x minus 4, this is where I can also do synthetic division. And the only reason why I'm showing y'all something is because it's a little different from what the majority of the problems y'all saw, or at least that y'all have seen recently in the packet. In sections 5 and 6 in that big packet, you were given a problem, you had to do the rational root theorem. I'm just making something up for the rational root theorem. And then you started with +1. So +1 in your box, 3, -19, 22, 20. If that didn't work, you would have done -1. 3, -19, 22, 20, so on, so on and so on. But I'm telling you to divide by x minus 4. So we're not pulling from the rational root theorem. What I'm pulling to get my number in my box is from the x minus 4. And if you need to go back and watch the synthetic notes video, you can. If you need to go back and watch the first video from the packet where I do section 3, because section 3 in the packet, they're all set up like fractions, but they're set up like that. So I'd be dividing that by x minus 4. You can do that. But what I have to remember is when I'm dividing by the binomial, I got to do the opposite sign. Well, why is that? Well, let's say I had 3 factors that gave me this, okay? I'm going to say x minus 4, 3x plus 5, which isn't right. And then x minus, none of these really are because it's going to be a remainder, but I'm just making it out. So x minus 4, 3x minus 5, x minus 1. I know it's kind of hard to see, but it's all equal to 0. That comes back to my zero product property. What cancels out -4 to make this equal 0? +4. So 4 is my root, x minus 4 is my factor. Again, if y'all remember from the packet, we had the factors, and then we had the roots listed, and you had to tell me if they were rational, irrational, real, or imaginary. And the roots and the factors had opposite signs. So when we were putting our numbers in the box here, we were pulling from our possible, I don't even want to say possible rational roots. I'll just say possible roots. So our root is what has to go in the box. X minus 4 is the factor. The root would be +4. So when I go to do my synthetic division with this, I'm going to have to put +4 in my box. I already have that set up right here. 4. Then I get 3x cubed. So 3 minus 19x squared, -19. 22x, 22 plus 20. Do your synthetic real quick. Again, other thing I want to note, again, a lot of these started with 1, but even if it starts with the 3, 3 still comes straight down. Then I bring it over. 3 and 4 is 12, -19, 12, -7, -7, 4, -28, 22 minus 28, -6, -6 and 4, -24, 20 minus 24 is -4. So that's my remainder. So if you're asked, what is the remainder? Again, it's not going to be the whole quotient. It's not even going to be -4 over x minus 4 in this case. It would just be A would be -4, B would be 0, C 3, D, I'm just making stuff up, -6, but you would pick A. Let me come back real quick. So if you're given a division question like this, if I gave you this as a division question, okay, so you don't even have that up there, 3x cubed, all that divided by x minus 4. So since this is 3x plus 2, I had to use long division. Since this is x minus 4, I can either do long, like I said, or synthetic. So we already had the synthetic set up, but now since the question is like this, it comes back to the answer I was looking for there, the entire quotient. So that's when I would have to label my numbers I got, and I would get 3x squared minus 7x minus 6 minus 4 over x minus 4. So again, I think y'all be able to solve the test based on the question, based on the answers, what you're looking for. If you're not 100% sure, again, you can ask me. And again, if I'll say, you got to divide and get the remainder, you got to divide. And, if you do long division, it's your entire quotient. If you do synthetic division, you divide, you get all your labels, and then get your new polynomial, which is really your quotient. So I could At least tell y'all that much. All right, moving on. Again, I'm trying to go relatively quick. So like I said, 5 or 6 division problems. So there's a few other questions that y'all are going to see that are more based on the packet. We still have to do some division. Okay. So I actually had the multiple choice answers written up so y'all can kind of see. If I tell you x cubed plus 9x squared plus 26x plus 24 has a root of -2, what is the complete factorization? That in its most basic form is taking one of those problems from the packet and turning it into a multiple choice answer. We got to pretty much do the same work. So I got the multiple choice answers. Okay. Y'all can see that it's all 3 factors. Okay. And I might even use the same one on the test or one pretty close to it. All the numbers are the same. They just different combinations of signs. All right. So this is where we got to remember. If I'm telling you -2 is a root, what that means is if I plugged it in here, everything would equal 0. It also means I could do synthetic division with -2 and get 0. So I would do synthetic division with -2. I'm not going to even change colors this time, just for the sake of trying to save time. 1 comes down, 1 times -2, -2, 9 minus 2, 7. 7 and -2, -14, 26 minus 14, 12. 12 times -2, -24, 24 minus 24 is 0. Remainder constant next to the first, x squared. So -2 is my root. Divided it, I get x squared plus 7x plus 12. I have a quadratic. Can I factor that quadratic? What can I multiply to get 12? Multiply to get 12 that adds up to give me 7, 3, and 4. So there's my last 2 factors. So I've already cut it down to A and C. But then I got to come back and remember about this being the root. If I'm trying to get the factor, again, kind of picture the I don't want to draw through that. Kind of picture the packet. I had my factorization. I had my roots down here below it. If -2 is my root, I said, okay, if I'm plugging in -2 here, this is going to be -2. What's got to cancel that out? +2. So my third factor would be x plus 2. So A would be my answer. So if you get this question, I might even put this one on here. I'm not guaranteeing it. Hopefully, if you're watching this video, you make a note of that. If -2 is the root, I know I can do synthetic division with it and go from there. Which of these is a factor of x cubed 9x? Again, I'm just using the same one just for the sake of easiness. Which of these is a factor of that polynomial? Well, we know it's a factor if we divide it and I get a remainder of 0. So you could do long division for all of these and see which one works out. Or you could do synthetic. But again, if I do synthetic, what I have to remember is 1, 9, 26, 24. I have to use +3 here instead of -3. If you did -3, -2, +4, and +6, I don't believe, and well, let me tell you that. I'm backtracking one second. If you did -2 and -3, both of those would actually work because of the way it's set up. But this is where you're going to have to remember, I got to use the opposite. +3 wouldn't work. +2 wouldn't work. -4 would work. Okay. So if you did x plus 4 up here, it would divide evenly. If you did it with synthetic, if you did long division, x plus 4 would work. If you did synthetic, -4 would work. So eventually that one would be, you would get a remainder of 0. When I say work, you would get a remainder of 0. Last question I want to show y'all. So I think I'm already at about 20 minutes. So that's a graphing one that we'll come back to. Last question I want to show y'all though is deals with the remainder theorem. And you can look. I don't think I actually have it filled out in the packet, but I don't. Some of the classes we did go over this in section, the beginning, or it's in section 4, top of the 4th page. Some of the classes we didn't. But what the remainder theorem states is if I divide and get a remainder of 0, whatever I divided by is a factor. So again, I'm going to use the x cubed 9x squared. So if I divide x cubed plus 9x squared plus 26x plus 24 by x plus 6, I would get a remainder of, let me actually do the math real quick. I said 8 in class. I just made it up off the top of my head. Let me see what remainder I would get. I would get a remainder of, let me see, good sharp pen. I'll do synthetic, make it a little quicker for myself. 1, 9, 26. -6, -6, 3, -18. I actually get -24. Okay, that's fine. Get a little bit of a bigger remainder, -24. But basically what we're trying to see here is if the remainder is 0 or not. Okay. So the question, let me stop sharing real quick. Just, I want to look up the wording. I'm not sharing with y'all. I have it pulled up. I want to see exactly what the wording says because I want to try to mirror it. I'm sorry. All right. So it's going to say something about the remainder theorem. Like according to the remainder theorem, I can't spell according. According to the remainder theorem, if I divide that by x plus 6, I would get a remainder of -24. So what does that tell me? So A would be x plus 6 is a factor. B, if I did F, let me pause. Let me stop again. I want to kind of, again, I want to try to mirror it as close as I can. Apologize. Okay. So what it says for B is if I divided what am I doing? 26x plus 24 divided by x plus 6. It's saying if I divide that by that, my answer is -24. Which again, we should know is not true based on what I already showed y'all. When I divided and got this, my answer wasn't -4, it was the entire polynomial. Okay. So it's not going to be B. C is going to say x plus 6 is not a factor. And D is going to say I made a mistake because my remainder, I know my handwriting's not the best, guys. I'm sorry. That's why y'all got to kind of listen. My remainder should always be 0. Well, I know my remainder. I know just, again, even if we just use simple division, 13 divided by 5, 2 with the remainder of 3, 21 divided by 4, 5 with the remainder of 1. I'm not always going to get a remainder of 0. So I know that's not it. I know B is not it. If my remainder was 0, it would be a factor, but my remainder is negative 24. So that means x plus 6 is not a factor. All right, so that's the review on long synthetic division and the questions that use the information that we learned about in the packet. Again, with the graphing stuff, I don't know if I'm going to make a graphing video. If I don't, I'll go quickly over it at the start of class before y'all test on Wednesday and Thursday. Hopefully this kind of helps y'all out. Good luck studying, and I'll see y'all in class.